Welcome back. Let's talk a little bit more about adding vectors, and what we're going to do is we're going to go hiking. Okay, so I'm going to, let's just assume this is kind of like a map. I'm going to start at some point A and I want to hike to some point B. And when we did this in the last video, all I did was I said, hey, let's just follow this path from A to B, and I called that vector L. I also called it R sub AB, but let's just go with L for now. Okay, but let's assume for a moment that there's something in the way. I can't go directly from A to B. So if I take a different path, let's say I choose a path and I've got to walk in straight lines. I choose this path from here to here, and then I can move to there. So there's some intermediary point here, C. So I could call this R sub AC, but for the sake of argument now, I'm just going to call this M. And I'm going to call this K. And so when I followed the path from A to C, and then from C to K, I ended up at B, as if I had followed the path from L. Okay? And so what I can say then is that the vector L is the same as M plus K. In the end, I'm at the same place. In the end, I'm at the same place. So L equals M plus K. L is equal to M plus K. Okay? Those vectors added together give me the same displacement. Let me call those displacement vectors. The displacement vector M plus the displacement vector K gives me the displacement vector L. So I end up at the same location, no matter which of those I've taken to get there. Well, let's follow a different path. Okay? Maybe I choose this path, but somebody else decides on another path. They might choose from A to this intermediary point D. There might be something at point D that they want to gain. Maybe there's somebody there they're going to meet. You know, they might want to go get a burger. I don't know what the case might be. And then they go finally to B. All right, so let's call this H and J. And so vector H plus vector J, that same path, I end up getting to B. And so I can say then that L equals H plus J. So I can add those two vectors together and I end up at the same place. Well, it doesn't even have to be just two vectors. It can be more than two vectors. So maybe I choose a completely different path. All right, so let me start at A again. I'm going to travel here. I'm going to call this point E. And I'm going to travel here and call that point F. And then finally, I travel there and I end up at B. All right, so this might be vector R, vector S, and vector T. And so following these three vector paths, I still end up at B. And so the final vector displacement L is the same as displacement R plus displacement S plus displacement T. So I can add those vectors together and I end up at the same spot no matter how I do it. Now one thing though that's of interest is sometimes when I add the vectors together, and I'm going to specify two vectors, I would like those two vectors added together to point in some special direction. And that special direction or directions might be horizontal and vertical. And so getting to L, I might want to follow this path to here. And I'll call that G. And I'm not sure I'm far enough over. And then this vector. Okay, and these are at 90 degrees. This is nice and horizontal. This is nice and vertical. Okay, on a standard XY plane, not every XY plane is going to be standard, but on a standard XY plane, the x-axis is horizontal and the y-axis is vertical. So this might be, instead of calling it, well, let me just call it U and W. Okay, so L equals u plus w. But what I like to do is I like to say, hey, u is the component of L, okay, the component of L, or the path along the x-axis to get to B. So I'm the component of L along the x-axis. So I'm going to call that L sub x. I'll still put a vector over the top of that. And W is the component of L along the y-axis. Okay, so U and W make two vectors, one along the x-axis only, one along the y-axis only, and when I add those together, I get the vector L. And so I call that component, or that piece of the trail, if you will, that portion of the path I've taken along the x-axis, I call that the x component of the vector L. And the y, I call that the y component of the vector L. And it turns out I could have done y first. So this would be W. It's in a different location, but it's the same length, same direction. And this would be U, same length, same direction as this U down here. It doesn't matter which path I take first. Traditionally, we do X first, simply because it's alphabetically before Y. But I end up at the same place. This is at 90 degrees in here. I end up at the same location no matter which path I take. And I could take all of these other paths. All right, so I could take the purple path, my apologies if you're colorblind, the red path, the green path, or this blue path, and I end up with the same final point. So my net displacement is the same no matter what. In all of these cases, I've traveled a displacement vector, a net displacement vector of L. Okay, I'm in the same place. So if this is 3 or 4 or 5 different people traveling from A to B along different paths, all of those people end up at point B. Okay, they all end up at point B. All right, so there's the beginning of our concept of vectors. If you have any questions, please leave them in the comments below. Thank you.